Hello everyone, I hope you like blinking LEDs just as much as I do. Although this video is not sponsored by JLC PCB, I still want to show you what I made using their services. The other week I received this package. In total I paid about €26, which included the cheapest shipping option. Next to a nice pen and some sticky notes, it contained the PCBs that I ordered a few weeks ago. The first board is for the TM1640 Mini 8x16 LED Matrix, which I showed in my recent live stream. I received 8 boards per sheet, making 80 PCBs in total. As you can see here, both front and back side are excellent. The quality of the board is great. The excellent tutorial series by Dustin Watts gave me great clues on how to design these boards online using the EasyEDA software. So let's open the second package. This PCB is a development board for the ATtiny44A MCU. On the board you can see room for the chip, a reset button and for pin headers. As each sheet has 6x4 boards, the 10 sheets give me plenty of boards. After JLC PCB raised the price for panelizing, Brian Locke showed us how we can panelize different PCB designs onto one board. This board was made using that technique. It contains 3 copies of a larger TM1640 8x16 LED Matrix, as well as 5 copies of the extended version of my ATtiny44A development board. To break off the individual boards, I use some ordinary pliers and a bit of force. The mouse bites at the edge of the board allow the interconnecting bridges to break easily. Using a few strokes of the file, the edges clean up quite nicely. To make an ATtiny44A development board, I use these components. The board only contains the ATtiny chip, a capacitor, a reset button and some pin headers. After snapping off a board from the sheet, a bit of filing is done to smoothen the edges. The ATtiny MCU is quite affordable, but be aware of fake chips. I first solder a single pin of the chip. The dot in the corner indicates pin number 1. When the chip is placed straight, I solder the other pins. The 10 microfarad capacitor has the 0805 size. It is quite small but large enough to hand solder with the iron. For the reset button, I like the golden color of these cheap buttons. Their pinout matches the footprint of the component I chose when designing the PCB. To put the PCB on a breadboard, I use these header pins. Using a small breadboard, they are easy to solder straight. Finally, I decided to use these red, white and blue colored header pins for the serial programming pins. The red pins go on the VCC side and the blue pins on the ground side. I'm quite happy how this development board looks with these colors. To test the board, I use a simple blinky sketch. I added an extra ground wire and 2 of my 8-bit LED strips. To power the board, I used a USB-ASP programmer and a USB power bar. As you can see here, it works just fine. Okay, the next board is the larger 8x16 LED Matrix. After breaking one of the sheets, I filed the edges to make them smooth. For this board, I first made this prototype. As you can see here, it has a TM1640 chip underneath and some transformer wire to connect the pins. On top I fitted 2 1088BS LED matrices using female headers. but unfortunately these headers don't fit exactly, making some iffy connections. So for the new board I first need a TM1640. I purchased these chips for about 20 € each on AliExpress. The dot in the corner marks pin 1, which I solder to the board first. I then solder the other pins. After checking if the soldering looks alright, I continue to fit the other components. On the side of the chip I solder a 10 microfarad capacitor. As you can see, they don't always cooperate. The ground side has a large copper area, which makes it harder to solder, so it's easier to first solder the VCC side. Next I solder on these two 10K pull-up resistors. As a connector I use some female pin headers bent to a 90-degree angle. The final step is to solder on the first LED matrix. Most important is to solder it parallel to the board. Once the first matrix is properly soldered, the second one can be put in place. When both are soldered level, without too much of a gap in between, the soldering is done and the module can be tested. For the first test I used the WeMOS D1 Mini that I used in my recent livestream. A small prototype shield with header pins connects to the module, and I used a ticker example of my TM16XX library to show this scrolling text. The TM16XX library now supports 5 different types of the TM16 chip family, and it has special classes for printing text or graphics and for reading button presses. In this final demonstration you can see that the ATtiny44 development board can also be used. I power it using a recovered 3.7 volt lithium battery. Although the ATtiny44 has much less memory than an EasyEDA, it uses less power and can still be useful. Here you can see the snake example, which can also be found on my GitHub account. Well, I hope you liked this video. If you do, you can subscribe to be notified of future videos. Bye bye!